Hello everybody, welcome back. Today we're doing the final section of 7.8, solving problems using quadratic models. Example 1, the engineers who designed the Coal River Bridge on the Alaska Highway in British Columbia used a supporting arch with twin metal arcs. So I'm just going to bring a diagram in. There's the bridge there. This is the arc that they're talking about. I'm sorry I don't have a head-on like picture of it straight on, but that's what the diagram looks like, just to give you an idea. Okay. All right. So this arch here is given by this function here. All right. The height of it is given by basically the y value, and the horizontal distance is the x value from one end of the bridge to the other. So here, here again. Sorry, that's the best picture I could find. But just to give you an idea of how this works in the real world, right? So it's given by this function. It actually works this way. So I'm going to do it algebraically, and I will do it graphically as well. So I'm going to do it graphically first so you can see it. So I'm going to plug this graph, and I'm going to use Desmos program. Again, you can use the graphing technology, of course, and you just have to open up your window. Okay, so I'm going to take this, I'm going to plug it right into Desmos now. All right, and there's your Desmos program. You'll see that I have the function in as given. All right, and it starts off at 0, 0, has a maximum height of 12.301 meters and a horizontal distance at 49.3 meters, and then you see that it's ending at 98.6 meters. So that means that the bridge has a length of 98.6 meters. Its maximum height of the arc there, so this is where the road would go across, right? So essentially what it would look like is you'd have the road going across at 12 decimal, whatever it was. 12.301, right? Like that's the blue line would be the indication that shows the road. Just to give you an idea what that bridge looks like, right? And dry. Okay? So that's that'll answer pretty much all the questions you needed to answer. So I'm going to take a picture of that for our work. Okay, so we have our graph. Got some information here. Determine the distance between the bases of the arch, then determine the maximum height of the arch, and there's 10. So this is 98.6. That answers that question. So the distance, steal this, the distance between the bases of the arch is 98.6 meters, right? And you get that information from the graph. It starts off at 0, 0, the origin. All right, so that would be like this corner up here, and where it ends here, you can't see it. Like I said, my diagram, that's the best I could find for that. Okay, and then determine the maximum height of the arch. The maximum height of the arch is 12 decimal, approximately 12 decimal, because we round it right, is approximately 12.3 meters, right? So that's the y value of the vertex. Now again, I'm going to do this, show you how to do this algebraically, and I'll show you how to get that right. So algebraically, we would have to take our equation and then we set it equal to 0. And you could easily factor this because there's no c value, so you can easily factor out a negative x. And by factoring out a negative x, you end up with 0 decimal. Oh, sorry. I take the whole thing. Sorry. Negative x, and you end up with 0.005061 x. And then if I just took a negative x out of here, then it just subtracts 0 decimal there, right? And you can go with positive x, it doesn't make a difference. So now we're going to set both factors equal to 0, all right? So setting both factors equal to 0, the first one here we set equal to 0, and the second one we set equal to 0. You can drop the brackets at this point. So obviously the first one is equal to 0, as we can see from our x equal to 0, right? If x is equal to negative 0, then x is equal to positive 0, obviously. Okay, or not positive, x, positive x, sorry. And the next one, we can just take the negative over to the other side by adding it, right? So over here, make it positive 0.4999015. Add it to both sides, it's gone. And now what we'll do is we will take the value and divide both sides, right? Once we have it to this step, we would divide both sides by 0.005061. That'll leave x by itself. Whatever you do to one side, you do to the other. So divide by 0.005061, right? And these are eliminated. That's why we did it. Anything divided by itself is 1, leaves you with x. So we end up with x equal to, I like the x on the left-hand side. So we take our, go to our calculator, decimal 4999015 divided by decimal 0.005061, and we get 98.600079004, right? So one place after the decimal is rounding unless it tells you otherwise, right? So that is 98.6. So there's the first x-intercept and the second x-intercept. If we look at our diagram, there they are. So a couple ways we can find the y value, right? Or sort of the x value of the vertex. Again, we know it's 49.3, so some of you would just say, oh, sir, let's just use the axis of symmetry, and I would say that makes a lot of sense. It's very simple, right? Remember, the axis of symmetry is x equal to, and remember, we just add the two x values that have the same y value, and obviously if we know the button there. If we know the two x-intercepts, in which we do, well, those both have a y value of 0, which is obviously the same. So this is a great formula to use, again, if you know 2 points that have the same y value, and obviously the x-intercepts do. So this would equal, and I would just take the two x-intercepts I just found there, 0 plus 98.6. This whole thing, this whole thing will be divided by 2, which is equal to 98.6 divided by 2, which is equal to 49.3, right? Which is the value we have up here. And we could also use the vertex, right? Remember I showed you how to find it using the x value of the vertex. And obviously the axis of symmetry is the x value of the vertex, right? So x value of vertex, we can also take it by x equal to minus b divided by 2a, right? So that's another possibility for the formula. If it's in general form, which it is up here, there's your a value, and there's your b value. So that would be equal to minus b, minus, and the b value was 0.499.015, and then 2 times the a value, which was negative decimal 0.005061, which would be equal to, it's going to be negative divided by negative, so it's just going to be the numbers, right? So it'll be negative 0.499.015 divided by, and we'll double that, we get decimal 0.005061 times 2, and we get negative 0.01. 1 to 2, and then we just divide those. Negative divided by negative is obviously positive. So we get 0.499015 divided by that, we get 49.3003952, which is obviously equal to 49.3 meters. Okay. And this was meters as well. So again, find that. And then obviously if you want to get the y value, we would plug that in. Okay. If you want to get the y value, we would need to plug that value in to the equation. So going back up to the original, there we are, and we can plug it in now. Okay. Everywhere we see x, we put 49.3, square that. And here our x is 49.3. So 49.3 squared, 49.3 squared, multiplied by negative .005.061, you get negative 12.3 plus, and 49.3 multiplied by 0.499015, we get 24.6, and add the two together. We get 12.3 meters. All right, so that answers all the questions, right? So that's the algebraic version. Obviously, graphing is seconds. All right, so there would be the arch of the bridge, and there would be the actual bridge platform, right? And as you can see from the diagram here. Okay. So obviously that's it for that example. That's it for time. In the next video, what we'll look at is example 2 on page 30 for that. Okay. So I hope the videos are helping, and we'll talk again soon.